Hi guys, this is Joy. In the previous lecture, we have taken the basic concept on parallel adders. Now, in this video, we will design and analyze the 4-bit parallel adder, subtractor, 4-bit parallel adder, and subtractor. As you can see, for what is parallel adder subtractor? It means that we will use the simple adder IC, same adder IC, that is 7483, for the purpose of both addition and subtraction with a particular control line which has been taken here by me, which is S3, and this is a control line. I am writing it add sub. It's not taking. So to give an underscore add sub. Okay, so it will simply control whether this IC will perform addition or it will perform a subtraction consequently. If this line goes high, then the result will be subtraction, and if this goes low, it will perform addition. Now let's check. Now in case of addition, we will take the control line to be 0. So here I have used a bus connection. This control line is connected through this C0, and all the second inputs, as you can see, of the XOR gates, all the second inputs of the XOR gates have been connected to this control line. Now this switch is for giving the B inputs through these XOR gates. These XOR gates have another inputs to connect it to these bits. This is B4, this is B3, this is B2, and this is B1. Simple. And the A inputs, that is A1 through A4, have been connected directly through this switch. Now, what is the significance of this configuration? It will be understood when I can simulate and make you understand how to design this kind of circuits. Now, as this control line is 0, so these XOR gates will be used as simple inverter, as I have told in previous videos in the basic gates, introduction to basic gates, when I explained XOR gate as control inverter. So this will act as simple buffer, so the inputs B1, B2, B3 and B4 will get passed to these inputs corresponding to B1, B2, B3 and B4 respectively. So same B inputs will passing through these inputs, and same A inputs will pass through these inputs. As I have taken here, A is 1111 and B is also 1111. The result should be 1 1 1 1 and 1 1 1 1. So it is 0 carry 1 1 carry 1 1 carry 1 and 1 final carry. So it is 1 1 1 0 and final carry is 1. As you can see, 1 1 1 0 and final carry is 1. Simple addition as depicted in the previous video. Now what is for subtraction? Subtraction will be performed by simply pushing this control switch to 1, and we will perform subtraction. What will be subtraction? During this control line to be high, we will get simply inverted B1 from this output. That means it will act as inverter as this control line is high. So B1 will be inverted. Here we should get B1 bar, here we should get B2 bar, here we should get B3 bar, and we should get B4 bar. So simply once complementing the inputs, and as you can see, this control line is also connected through to this initial carry C0. So this initial carry gets 1, so ultimately we are getting the 2's complement of B, and finally adding A with B and getting the subtraction result by 2's complement method. As I have previously depicted that all addition in logical circuit, subtraction rather in logical circuit is performed by addition. Now let us take two inputs, say it is 1101 and say it is 1011. So it is 1 minus 1 0, 0 minus 1 it is 1, borrow 1, 1 plus 0 it is 1, so 1 minus 1 0, and it is also 0. So it should be 0 0 1 0, and I'm getting inputs 1 1 0 1, so it should be 1 1 0 1, and it should be 1 0 1 1. There I am making a mistake. 1 0 1 1, and it is 1 1 0 1. As you can see, it is 0 0 1 0 as found here. 0 0 1 0. Simple. And in one thing you should note carefully, that during subtraction you need to eliminate this carry or final borrow output, because from whenever we are subtracting a smaller number from larger number, this borrow is just an unambiguous nature of the circuit. It should be eliminated, and you should not take care of this borrow out. You should only be concerned about this difference output given by S1 S2 S3 and S4. So bit complex than the previous, but simple if you know the connections properly, if you know the devices properly of multisim, and if you know the proper operations of XOR gates, the buses and the switches and the LEDs, etc, etc. And one thing is worth to remember, that in the previous lecture, during demultiplexing, the IC was giving active low output, but here the IC is giving high output, so we are connecting anodes to these outputs and grounds to the cathodes, so that the circuit becomes full and the LED is forward biased and it glows up. So simple. Be careful, don't do the mistakes. So that's all for today. See you next time.